Today's video we're going to discuss the refrigeration cycle. But before we move into the cycle itself, there's a few basic concepts I'd like to go over, just to make sure we're on the same page. First thing I want to talk about is heat. It's important to know that when we're talking about air conditioning a space, that we understand that we cannot create cold air. The only thing we can do is remove heat from the air. Another thing to keep in mind when we're talking about heat transfer, the heat always moves from hot to cold. And the bigger this difference is from the hot to cold, the faster this transfer occurs. The next thing I want to talk about is saturation and boiling points. Basically, this is the point at which a liquid is either going to condense or boil off. When we're talking about a refrigerant, this term is interchangeable depending on what we're talking about. If we're talking about a saturation point, then we're talking about a vapor gas. At what point is it going to condense back to a liquid? Or vice versa, if we're talking about a boiling point, we're talking about what point this liquid refrigerant is going to boil off into a vapor. The point's the same, it's just kind of a difference in terminology in what we're trying to achieve here. It's also important to remember that this point is affected by pressure. We can manipulate it. So the greater pressure we exert on our refrigerant, the higher this boiling or saturation point is going to be. And the less pressure there, the lower that temperature is going to be. The last thing I want to talk about is superheat and subcool. Basically, superheat is the amount of heat added above a refrigerant's boiling point. For example, let's say the boiling point of a refrigerant is 40 degrees and the temperature we're measuring is 50, then we've got 10 degrees of superheat. The importance of superheat to us in a refrigeration circuit is if we have superheat, it ensures that all the refrigerant is in a vapor state. Subcool is the exact opposite. It's the temperature that we cool the refrigerant below its saturation point. For the same example, if we have a refrigerant and the saturation point is 40 degrees, we measure it and it's 30, so we know we have 10 degrees of subcool. And where that's important to us in the refrigeration cycle is that we have 100% liquid if we have subcooled refrigerant. So here's the basic refrigeration circuit laid out in a loop. Makes it a little bit easier for us to see all the components and kind of how it works and to see how it works in a cycle, a continuous cycle. Basically, the basic components we're going to go over is just the bare bones. We've got the compressor, the condenser coil, the liquid line filter dryer, the metering device, and the evaporator coil. Basically, that's all you need to create a refrigerant circuit. First, I want to start with the compressor. Compressor is the heart of the system. It basically is what pumps all the refrigerant through the entire cycle. It's important to know that it is a vapor pump. It's not designed to pump liquid. You can't compress a liquid. If you do, you're going to damage the compressor. So it's important that we don't get any liquid refrigerant into our compressor. So what we're doing is on our suction line, we're receiving a low temperature, low pressure, superheated gas. It moves through the compressor and it compresses it. As we compress it, that raises the pressure, which also raises the temperature. So when we exit the compressor, we've got a high temperature, high pressure gas. We move on the discharge line into our condenser coil. At our condenser coil, we have a fan that's blowing outside air across the condenser coil that the refrigerant is traveling through. And even though it may be a 95 to 100 degree day, that air is still cooler than the temperature of what's inside of our condenser coil. Going to get it below that saturation point. So as our refrigerant moves through the condenser coil, it begins to cool down and the heat's released out into the air. And we make it to our saturation point and become a liquid, and then we eventually become cooled below that point where we have subcooled refrigerant. We then exit the condenser coil down the liquid line and travel through our liquid line filter dryer, which does exactly what it says. Basically, it's filtering debris and moisture out of the refrigerant. We continue to the metering device. When we get to the metering device, basically this creates a pressure drop. There's different types of metering devices out there. We've got TXVs, which stands for thermal expansion valve, or we've got fixed metering devices such as pistons or orifices, whichever one you choose to call it. It creates a pressure drop. When we drop the pressure, we drop the boiling point, and we move into the evaporator. Once we get into the evaporator, we're moving the warm return air across the coils, and the refrigerant starts absorbing that heat and begins to reach its boiling point and boil off into a gas, and eventually becomes superheated before we exit the evaporator coil. And then we repeat the cycle and take that superheated gas back to the compressor and move back through. So in summary, the basic refrigeration circuit is going to consist of your compressor, which is the heart of the system. And also remember, it's a vapor pump only. Let's not get any liquid back to that compressor or we're going to cause damage. We're going to go to our condenser coil, which has three basic functions. We're going to de-superheat that gas, bring it back to its condensing point, condense it, and we're going to subcool it to ensure we got 100% liquid exiting our condenser. It's very important. When we move to our filter dryer, we're going to remove moisture and debris. When we move to our metering device, which basically causes a pressure drop. We move to our evaporator coil, which has three functions as well. We're going to de-subcool that gas. We're going to bring it to its boiling point and evaporate it off. And then we're going to superheat it to ensure we got 100% gas getting back to our compressor. And it's just a continuous cycle.